Welcome back, second video in the series. So we were dealing with linear models. We left off with this question, and another way linear models can be tested is SAT will give you a list of values, x and f of x, or domain and range of values, corresponding coordinates, whatever you call them, where you're from, and you need to create the linear model. You need to create the linear equation from that. So before I jump into the question, remember, this is the general form of a linear equation. M is the gradient, C is the y-intercept. So look at the question again and see if you can get the answer. The trick with these questions is to find the gradient, find the y-intercept. How do we find gradient? Most of you all should know it already. Changing the y coordinates over changing the x coordinates, changing y over changing x, or we use y2 minus y1 over x2 minus x1. And this is like your y and this is like your x. So we can find a gradient real simple for this by plugging in y2, y1, x2, x1. We find that the gradient is supposed to be 4. C is the only one that has a gradient of 4, so C is the answer. Another question, almost identical to the one just completed. So have a look at it, see if you can get the answer before me. Pause the video if you have to. The table above shows some values, linear function f, n maybe like our x values here, f of n is like our y values here. So boom, bang, we want the gradient to be something. Let's figure out what the gradient is, because I'm seeing all of these have a different gradient, all of the answers. So out pops my gradient formula. Some people do this, x2, x1, y1, y2. Just give them a little guide. So this is like 1 minus negative 2 all over 2 minus 1. When you substitute the correct values. Now you could use any group of values, any two pair of values, and that's the gradient. C must be an answer. Simple things. So this last question is a bit more tricky, but it's the same concepts. See if you can figure it out. Pause the video, see if you can get it. I have already started here. I substituted x1, x2, y1, y2. Let's put it in. Negative a minus 0. 3a minus a. This leaves us with minus a over 2a, a gradient of a half. Nice. I can see if I rearrange a and b, I will get a gradient of negative a half. Will that happen with c? No, it won't. These two out. But how do we know if a and b? We need to find the y-intercept. Y is equal to mx, but m is actually negative a half. We got that. Plus c. C is what we are trying to find. Let's substitute two values for y and x. How about that 0 and a? That looking good. So y is 0, x is a, c is a over 2. If I put in what I know for m and c, this is the equation I get. Let's multiply everybody by 2. And rearranging this, the only answer I can get is a. Did you get that for this question? Take your time, watch it over, see if there's anything that needs a little explanation. You can ask in the comments and I'll try to get to it in the comments. In the meanwhile, just press like and subscribe. I have one more video to do on linear models, and I think it will help you to mash up the SAT exam. So love and blessings.